You spot a spider on the wall. You grab a tissue, you move slowly, carefully, and before you even get close, it's gone. Most people think the spider saw them, but here's the truth. Most spiders have genuinely terrible vision. It didn't see you coming. It felt you. And the system it used to do that is so precise, so sensitive, and so deeply strange that engineers have been trying to copy it for decades and still haven't gotten close. Covering each spider's body are thousands of microscopic hairs called trichobothria. Not regular hairs, biological tripwires, each one connected directly to a nerve ending, permanently active, permanently listening. Here is how sensitive they are. You know how a blade of grass bends in the lightest breeze? That's millions of air molecules moving simultaneously. These hairs don't need millions of molecules. They can detect the displacement of a single air molecule. Think of it like a burglar alarm, so sensitive that even the air moving around your body as you walk is enough to trigger it. Before you make a sound, before you touch anything, before you even get close. And underneath those hairs, embedded directly in the exoskeleton, is a second layer of sensors called slit sensilla. These don't detect air, they detect vibration traveling through surfaces. When you take a step 2 rooms away, that vibration travels through the floor, up the wall, and directly into these sensors. How sensitive? Less than 1 nanometer of movement. That is roughly the width of 10 hydrogen atoms placed side by side. The spider is detecting your footsteps at the atomic scale, through a wall, from across the room. So by the time you spotted that spider and reached for something, it had already felt your arm moving through the air. It had already felt your footsteps through the floor. It had already calculated which direction you were coming from. You never had a chance. The spider didn't run from you. It responded to data you didn't know you were sending. Now here's the part nobody talks about. Web-building spiders don't just have sensors on their body. They've built themselves an external sensory organ the size of a dinner plate, the web. Most people think of a web as a trap, but that is almost a secondary function. The web is a satellite dish, a seismic sensor, an early warning system that extends the spider's sensory reach across an entire room. Every silk thread is under precise tension, and silk under tension behaves like a guitar string. When something disturbs it, an insect, a footstep nearby, a change in air pressure, it vibrates at a specific frequency. The spider reads those frequencies the way a musician reads notes. Different frequencies mean completely different things. A struggling insect produces a chaotic high-frequency vibration. Wind produces a slow, irregular movement. A large animal approaching produces a specific low-frequency ground vibration pattern. The spider doesn't just feel that something touched the web, it identifies exactly what that something is from the frequency signature alone. But here's the detail that changes everything. Research from Oxford University found that spiders actively tune their webs, not passively, not by accident, deliberately, the way a sound engineer adjusts a mixing board. By changing tension in individual threads, the spider adjusts which frequencies the web is most sensitive to. Hunting for food, it tunes to the insect frequency range. Sensing a threat nearby, it retunes to pick up the low ground vibrations of large approaching animals. A web that reconfigures itself based on what the spider needs to detect. And the range of this system extends far beyond the web itself. Studies show spiders can detect vibrations transmitted through floors and walls from several meters away. Your footsteps in the hallway, your hand reaching for the light switch, your weight shifting as you lean forward to look at it. All of it is data. All of it is received. You haven't been living with a spider in the corner of your room. You have been living inside its sensory field. Now, if you watched our cockroach video, you already know some small creatures don't rely on a single centralized brain. The spider takes that concept even further. Its nervous system has processing nodes distributed throughout its body, including directly inside the legs themselves. What this means is that a spider's legs can begin responding to a threat before the main brain has finished deciding what the threat actually is. Think of it like your hand pulling away from a hot stove before your brain registers the heat. But instead of a simple reflex, it's a full coordinated escape response, choosing direction, speed, and route simultaneously. The result is a spider that goes from completely still to full escape in under 50 milliseconds. The same number we saw with the cockroach. Evolution keeps arriving at 50 milliseconds as the threshold below which a small creature becomes effectively impossible to catch by surprise. And because the system is decentralized, spiders missing several legs redistribute the processing load across remaining legs almost immediately. No single point of failure, no central processor you can interrupt. 380 million years of refinement packed into something living in the corner of your ceiling. You have been trying to sneak up on 380 million years of engineering with a tissue. So let's go back to that moment. You spotted the spider, you reached for something, you moved carefully and quietly across the room. Now you know exactly what happened. Your arm displaced air that the Trichobothria felt from across the room. Your footsteps traveled through the floor at the atomic scale directly into its exoskeleton. Its web had been tracking your movement since you entered the room, and its legs were already moving before its brain finished deciding what you were. You were never sneaking up on it. You were walking through its sensory field, broadcasting your presence on every channel simultaneously. The spider in the corner of your ceiling knows your patterns. It knows the difference between you walking toward it and you walking past it. And it has known that longer than you knew it existed. Subscribe to Microminds and find out what else has been watching you.